So we wrote our first test here, and the test works, and it's actually not a bad test, but it's also not perfect. Because whilst it does its job, there are a couple of flaws with this test. Specifically, it's not following the AAA pattern, the arrange, act, assert pattern. But what is this pattern all about? Well, in the end, it's about three phases. The arrange phase, where you want to define the testing environment and values you are using in the test. Then the act phase, where you perform the actual testing, so where you execute the function that should be tested. And then the assert phase, where you evaluate the result and you set your expectation and you simply define which results lead to a success and which results lead to a failed test. Of course, in this test we have an expectation, and of course we are executing the add function. But we're not really arranging our values. We're just creating an array on the fly and we're passing it here into add. This works, but this test gets a bit easier to read and change if we actually do add a separate constant here maybe, which contains these numbers, and we pass this constant into add. If we then ever want to change our numbers, we can do this here and we don't have to touch this line of code. Of course, this is a super simple test. It's not too bad if we would have to change it here, but still, splitting it like this makes the overall test a bit more readable and will make it a bit easier for your fellow developers to dive into the same test and change it. So this here is the arrange phase. This here is the act phase. So here we act, we execute this function and we store the result. And then we have the assert phase here. But there we also can improve it. Here I hard-coded the expected value. The problem with that is that if I ever change the inputs here, because I want to change the details about this test, and I forget to change it down there, then of course, if I navigate back into the folder and I run this test, you will of course notice that it fails. It fails because my expectation is wrong. The problem is if I don't realize this quickly enough, I might start looking for an error here inside of this function. Because that is the general idea behind tests. You want to see whether your function, your unit, does its job. And you might try to fix the function or unit if your test is failing. But of course, this test is failing because my expectation is wrong. Therefore, instead of hard-coding the expected value like this, it often is better to calculate the expected result. So here I could also arrange my expected result by using numbers and calling the reduce method on it, which is a built-in method you can execute on arrays, to have a starting value, and then pass a function to reduce, which is executed for every array value, where you get the previous value and the current value, and you then return prev value plus cur value. If the reduce method is totally new to you, again, definitely check out some dedicated JavaScript resources first. In the end, what this does is it executes the expected result. You don't want to call add here because that's the thing you're testing, so you don't want to use the add function here to calculate that. You instead want to calculate it here inside of this test. And then the expected result can be used down here. By the way, you could of course also move that code down there because you can argue whether we are arranging the test here or if we're just arranging the, well, expected result. Ultimately, it's up to you. It's just a good idea to derive the result programmatically here inside of the test. And if you do that, of course, now the test will succeed again because now we are expecting the right value. But this AAA pattern is really a pattern I do recommend because it keeps your tests organized and structured. So I will of course also use it throughout this entire course. Okay, so at this point we learned how we can write tests, that we should use the AAA pattern, that we also should write more than one test to also check different scenarios and also check for certain things we don't want to happen or certain values we expect to get if invalid values are passed in. And with that, we already learned a lot about writing tests. But is that all we should do for this add function, for this unit? Should we write more tests? Well, generally, this answer is impossible to answer because that depends on you and your expectations. You want to, of course, be pretty thorough. You want to think about a lot of different scenarios that could occur and write appropriate tests. But ultimately, writing good tests is an iterative process, which means you write your tests and then you continue working on your code. And maybe you also work on different code in a different file, but at some point you come back and you change something here and you see that, oh, I should now write a new test to handle some new case, some new possible invalid value that could be passed in, or anything like this. So it's possible that you should write more tests, but it always depends. You can, of course, and you typically will, add more tests over time, because the more you work on a project, of course, the more ideas you have on how a certain unit could be used incorrectly, or how it should produce different values in different situations, and then you always want to check your existing tests and see if they do cover all these main scenarios you can think about. And therefore, there is no right or wrong answer, but you always want to be open to adding more tests, and you always want to think about possible values, invalid values, maybe situations where things could crash, things like this. Now here, for this function, there are at least 3 more tests which I do want to write, though of course I will say that it wouldn't be horrible if you don't add them, but I have 3 ideas or 3 tests that make sense to me here. The first new test which I do want to write here is that I want to check if the function yields 0 as a sum if an empty array is provided. Because an empty array is of course a special kind of input value, and maybe the function could also crash if an empty array is passed in. Or maybe your expectation is that it should crash. There are different expectations you could have. Here my expectation is that if an empty array of numbers is passed into the add function, it does not crash, but it returns 0 as a sum instead. Therefore, I will arrange a numbers array which is empty. I will then call add and pass in my empty numbers array and get that result. And then my expectation is that result is 0 with the to-be function. So that's one additional test I want to write. In addition, I want to check what happens if I don't pass in any number. So if no argument is passed into add. And I would say it might make more sense that we get an error then. So it should throw an error if no value is passed into the function. That's my expectation here. And again, you could have a different expectation, but for me here, it makes sense that if I call a function called add without passing in any values, that I then get an error. So therefore here, I don't even have an arrange phase because I don't want to pass anything into the function. And instead, I'll get my result here and I pass no value to add. But how do I now write that I expect this to throw an error? Because an error is not really a value returned by this function. Instead, as you know, in JavaScript, errors bubble up. So therefore, how can we check whether add caused an error? Well, for this we have to change our code here a little bit. Now we did learn about this AAA pattern in the previous lecture. Another thing I want to mention here about writing good tests is that you want to keep your tests simple. This is really important to me because it's easy to build an overly complex test. And here it would already be a bit too much if you start adding a bunch of numbers in here. Of course it will still work, there's nothing wrong with it, but which value does it add if you add more numbers? Of course, if you want to test whether the function maybe doesn't work correctly anymore with more numbers, then this could be a reason, but this shouldn't go into a test that just checks whether the numbers are summarized. For that, it's sufficient if you have 2 numbers in that array. So you want to keep your tests as simple and concise as possible, and you don't want to make them unnecessarily complex. Because you always have to think about yourself coming back to a test after a couple of weeks, or maybe a fellow developer diving into the test. And everyone should be able to quickly understand and, important, change this test if needed. So keep things simple as we're doing it here. And that, of course, was a lot of talking about the first test, but this is the foundation for the entire rest of this course and for your testing career in general. So now with that out of the way, let's dig a bit deeper into tests and let's see which other kinds of tests we could write. So how can we check whether a certain unit, a certain function, produces an error? As mentioned, we can't look for the return value because an error is not returned in JavaScript and in many languages. Instead, it's thrown. So we have to catch it here. Now we could try wrapping this in try catch because a test is just regular JavaScript code. So of course we can try something and catch an error. And then we could expect that error is to be defined so that we have an error, for example, something like this. This would work, but an easier way, at least in my experience, is that we instead add a new constant, which we could call result fn for function, though the name is up to you. And this constant or variable holds a function as a value. In this case, an anonymous arrow function, but you could also use the function keyword or use a named function. It does not matter. But here I'm storing an arrow function in result fn, and inside of this arrow function, I call add with no value passed in. But now this code in this function is not executed when the test is executed. Instead, it's only executed when this function here is executed, which is stored in this constant. And I want vtest to execute this function, which it is able to do if I expect result fn to throw. When we use to throw like this, expect should receive a function, and vtest will execute this function for us and check whether it throws. So that saves us the hassle of setting up our own try-catch blocks. And Jest supports a similar syntax. So by wrapping this code into a function, we can make sure that it's not executed immediately, but instead in combination with toThrow, which checks whether an error was thrown, this function stored in result fn will be executed by vtest when the test runs, and vtest will check whether an error was thrown and then consider the test successful if an error was thrown or not successful if no error was thrown. Now with that, if we now run npm test, all tests pass because it looks like I am getting an error here. Now, of course, maybe you don't want an error. You could easily check for the opposite by adding .not in front of toThrow. And this not property, which it is in the end, exists for all these two functions. If you want the result not to be 0, you could add not here as well. And please note how this reads like a nice sentence. Expect result not to be 0. Expect result fn not to throw. So by using not, you can easily check for the opposite. Now I don't want to check for the opposite here, so I will remove it. And I also don't want to check for the opposite here, but I will show you that it would fail now if I check for the opposite. Now it fails because now I'm saying that I don't expect this to throw. So I don't expect add to throw an error if no value is passed in, but it is throwing an error. I am getting an error that says numbers is not iterable. So of course I don't want to check for this here, but I wanted to show you the not property because this allows you to check for the opposite with any to function. And I wanted to show you that this really throws an error, and therefore, of course, typically, without the not property, we have a passing test because we're expecting it, the add function, to throw an error. So that's how you can check for errors and for the opposite with not. Not is not directly related to errors. I just wanted to introduce it as well. So which other tests could we write? Well, we got plenty of other files with other functions and therefore other units. Right, but we're not done with the math.js file. Typically, I would almost say always, you should not just write one test for a unit. Because with that one test, you are testing only one thing typically. Here we're testing if we really summarize all number values in an array. But we also want to test a couple of other things. For example, we also want to test a couple of things that should not happen. So here I will add a second test here in math.test.js. And what I want to test is that it, so the add function, should yield NaN if at least one invalid number is provided. Because of course that's also something we want to make sure. If we're building a complex app, a complex website, then of course there could be a bug where we have an add function like this, which also works if invalid values are produced. And it would then work, but also yield invalid values. And that's an important thing to test, because if this would be a bigger application, then of course maybe we're using the add function in some place where for some reason an invalid value is passed in. That's definitely not unthinkable. And if that happens, this function might maybe crash or throw an error. Of course, we might know that this function doesn't, but the idea behind tests is that you do specify what should or should not happen. Because even if the function works a certain way right now, other developers might change it in the future and it then might not work as before anymore. So it's important to define as many expectations with as many tests as possible, as long as it makes sense, of course. So here what I want to do is I want to arrange a new array of inputs. And in that array, I now got something like invalid. So this is not a number. It's a string, and it's especially also a string that contains a value that can't be converted to a number. And then I might add another number into it, a regular number. So that's our arrange phase. Then again, I will execute add on this inputs array, and I get back a result. And now my expectation here is that the result is this special not a number value. Of course, you could have a different expectation. Maybe the expectation is that you do get an error. Whatever, it's up to you, it's your code. But here, for this demo, my expectation is that I get back not a number. So therefore then I expect result to be, and then we got this to be NaN for not a number method. So we just have to execute it like this, and with that we expect result to be not a number. If we now run npm test again, this fails though. I don't get not a number. Instead, here you see that in the end I expected this output to be not a number. So that's the actual output which I got. It looks a little bit different than it did before, where we did have this expected and received output, but we can still see what we expected and what we got. So that's what we got. And why are we getting this? Because our code currently doesn't work the way we want it to. And that is the idea behind tests and behind writing different kinds of tests. We want to make sure that our code works the way it does. I could write another test before we fix our code that also would prove that the function currently doesn't work as intended. The add function, I mean. Because it should yield a correct sum if an array of numeric string values is provided. That would be another expectation I have here for this function. And with numeric string values, I mean that we have an array of inputs or an array of numbers. This name, of course, is up to you, where we have numbers which are technically of type text though. So not numbers as we had them here, which are real numbers, but instead numbers which are wrapped in quotes and which are therefore technically text. I would expect to get a result if I call add and I pass my numbers to add, where this result is, in the end, 3. And we don't want to hard code this, as you learned, so instead I will derive my expected value like this. And very important, I will add a plus here in front of cur value and priv value to force a conversion to a real number, so that my expected result here is indeed a real number. Alternatively, you could also hard code it, but you want to avoid it if possible. Of course, the danger with calculating a result here is that you introduce an error here and you therefore have an incorrect expectation. So if your tests fail, you always want to check your expectation values as well. But here it should be correct. With that, if I run npm test, I got 2 failing tests now, as you can see, and this test, this new test which I added, also fails. This should yield a correct sum if an array of numeric string values test. It fails because I expected 3 as a result if these 2 numbers were added as numbers, but I got back 0, 1, 2. And I got back 0, 1, 2 because that is how JavaScript works in the end if you combine a number with strings. In the end, what JavaScript does then, if you use the plus operator on strings or on numbers in strings, is it will concatenate all these strings to one long string. And that's why indeed we don't get the expected results here and here, because it's not trying to generate a number, which would give us not a number if it fails, but it's simply concatenating strings instead. Hence here our tests, because we wrote multiple tests, detected a problem with our add function. And that's the idea behind tests. You want to detect problems either in your code right now, or even if all the tests pass right now, in the future, if the code maybe gets changed by a colleague or maybe by yourself. So here we want to also force a conversion by adding a plus in front of number here, so that for all the elements in the array which we're getting, we are converting every element to a number before we're adding it to the sum. And then we will get not a number, NaN, as a result if it isn't a number, or we will get the sum if it's possible to calculate a sum. By making this change here, if I do run npm test again, now all tests pass, as you can see here, because we fixed our code. That's the idea behind tests, and that's why you should write more than just one test.